Uh, Hi guys, I'd like to introduce you to the very first video I'm going to do. This is going to be a math tutorial for my calculus class, although others can watch if they really want to. I'm going to be going over some of the problems in the lesson on the homework to try to help you out. I don't really know what else to say. I'm not really very prepared. But I think you'll get better. So I wrote the assignment here. I don't know if you can read the numbers or not from where the camera is, but I wrote the numbers that I'm going to be going over in blue and the other numbers in black. I'm going to try to pick a representative problem set because I don't want to do them all. Also, that'd be cheating. So I guess let's just get started. This is my homework, so no copying. So the first problem I'm going to do is problem 2. And in your book, you have a problem or a picture that looks somewhat like this, and it asks you a bunch of questions about it. So, 2A, this is question 2. 2A says state the values of f of -4 and g of 3. So this is a pretty simple problem. F of -4. You look at the graph of f. This is the red one here. And go over to -4, and then go down to see what the function tells us. So that's at -2. It's a little hard to see, but that's the answer, -2. And g of 3. So now let's look at the graph of g, which is blue here. Go over to 3, 1, 2, 3, and then go up to see what it is. 1, 2, 3, 4. It's at 4. And that's the answer. So f of -4 equals -2, and g of 3 equals 4. So now 2b asks for what values of x is f of x equal to g of x. So this basically means where, as an x value, do the graphs intersect? Do they equal the same thing? So they intersect right here and right here. And that is at x equals -2 and x equals 1, 2. So x equals -2 and 2. 2c. Estimate the solution of the equation f of x equals -1. So when f of x equals -1, f of x equals -1, whereabouts is the x value? 1, 2, 3. I count -3. And I think that's what I put. Oh, and 4. Because it also equals 4 up here. -1 right here at 4. So I kind of messed up on that one, so I'm going to do it again. So when we count over to f equals -1, it equals -1 in 2 spots. So we go over 1, 2, 3, -3, and 1, 2, 3, 4 at 4. So the answer is x equals -3 and 4. Now 2d states on what interval is f decreasing. So if we look at f, the red graph, you can see that it's decreasing from 0 to 4. I hope you guys all can see this. It's going down to the right. In other words, the y value gets smaller as the x value increases. I think that's pretty basic. So yeah. 2e, state the domain and range of f. I'm not going to do 2f because it's the same thing. But so the domain and range of f. Let's start with domain. Domain is the x values. So how far to the left does it go? 1, 2, 3, 4. -4. And how far to the right does it go? 1, 2, 3, 4. All the way to 4. So what I wrote here, I don't know if you can see it, is -4 is less than or greater to x, which is less than or greater than or equal to 4. Yeah. Okay, that will do it for 2. Now I want to do a couple of these. I'm going to start at 5 and do, I think, 5, 6, 7, and 8-ish. I'll do a few of these because they're really easy and kind of fun to draw. So I'm just going to use this graph here, and 5 looks like a graph kind of like this, ish. So, and it's asking us whether to determine whether the curve of the graph is a function of x. And if so, state the domain and range. Well, so to find out whether it's a function, we use the vertical line test. And as you can see right there, it crosses 3 points, so it's not a function. So you don't have to do anything with it. 6 is a function. I'm not really going to go over that one. 7 is a function also. It looks like something like this. Something like that. Where there's an open dot at -2 and a closed dot at -2 again. So if we draw the vertical line, even right here, which is where one might suspect that you might get 2 lines, it only passes through this solid dot right there, and it doesn't pass through this open dot right there. The open dot means that it goes up 2, but it does not include -2. And the closed dot means that it goes down 2 and does include -2. So that is a function. And 8 is not a function. The vertical lines looks kind of like a step pyramid thing. The vertical lines represent an infinite number of dots on the same x value. So if we drew a vertical line right there, it would be intersecting this vertical line an infinite number of times. So it's not a function. What's next? 19. Next we're going to jump over to 19. So, hold on while I erase this. So 19 is asking if f of x equals 3x squared minus x plus 2, find f of 2, f of -2, f of a, f of -a, and a bunch of others. So I'm not going to do the simple ones. I'm going to jump to the more complicated ones, and I have the book right here. So let's just write the equation up here. 3x squared minus x plus 2. So let's do f of a plus 1. So basically, whenever you see an x, you put a plus 1 in. So it'll look like 3 a plus 1 squared minus a plus 1 plus 2. Then you can just simplify it and do the rest of it. I'm not going to do that for you because you guys are big kids and you are in calculus. You can do that. Let's do this one. It's f of a quantity squared, and it's the one with the little brackets like that. So you basically just do f of a, so 3a squared minus a plus 2, and then you square the whole thing. And I would not simplify that. I just leave it like that because it's pretty nasty. So I think that's all I want to do for question 19. Question 20 is a little tricky. It's the start of a word problem. And it is saying a spherical balloon with the radius of r inches has a volume of v of r equals 4/3 pi r cubed. Find a function that represents the amount of air required to inflate the balloon from a radius of r inches to a radius of r plus 1 inches. So this is basically asking, we have a balloon that has a radius of r, but we want to increase the radius to r plus 1. So we're basically adding 1 unit to the radius. And it's asking what the volume of air is to do that. So, as many of you can see, it's r plus 1 minus r. But that's not the equation. But that is the premise. So we're going to start out by finding v of r plus 1, which equals 4/3 pi r plus 1 quantity cubed, and that's it. Now we'll find the volume of just regular r, and that equals 4/3 pi r cubed. That one's really simple. So then all you have to do is do the r plus 1 minus r. So let's do 4/3 pi r plus 1 cubed minus 4/3 pi r cubed. And I left it like that. R plus 1 cubed gets pretty ugly and it doesn't simplify very well. So I think it's prettier just to keep it like that. And that's all I did. It's pretty simple once you get the hang of it. I don't know how many of you thought it was hard. Maybe you all thought it was easy. In which case I'm just rambling on for no reason. 25, I think. Oh, yes. So 23 through 27 wants you to find the domain of the given function. 25 is f of t equals the square root of t plus the cube root of t. So, to find the domain, we have two things to keep in common, or to keep in mind. We don't want to divide by 0, and we don't want the square root of a negative number. Those are the only two things we care about. And in this situation, since we have a square root, I think we're going to be more worried about the second condition, that we don't want to divide or have the square root of a negative number. So this is really easy, just the square root of t. T can't be negative. T has to be greater than or equal to 0. And that's the answer. What's the next one? Oh, 47. This was another tricky one. I have a feeling many of you were confused with question 47. That is okay. It is pretty, at least fairly cryptic. So the way I went about it is I drew a diagram first. So let's draw a rectangle. Actually, I should probably read this to you first. I'm going to do that. So question 47 wants you to find the formula for the described function and state its domain. So a rectangle has a perimeter of 20 meters. Express the area of the rectangle as a function of the length of one of its sides. So this seems pretty easy. We know that the area of a rectangle is just the length times width, right? Just x times y. But we want to find the area based on just one side length, which is a little more tricky. But they do tell us that the perimeter is 20. So P equals 20. And this is, call that x and call that y. So the first thing I did was write out the general formulas for perimeter, which is the perimeter equals 2x plus 2y. Seems pretty simple enough. Then I wrote the general formula for the area of the rectangle. Area equals xy. So the next thing I did was to solve the area equation for y. So when you do that, you come out with y equals a over x. A is the area. And I think I'm going to switch to a darker pen. So then what I did was I substituted this equation. Now we know what y equals, right? So we can substitute that in for y in the perimeter equation and just have one variable, or two variables. So the perimeter equals 2x plus 2 times a over x. A over x. But we also know what the perimeter is, and the perimeter is 20, right? So let's plug that in. 20 equals 2x plus 2 a over x. And I see a common term that we can get out, so we just divide the entire thing by 2. And we will get 10 equals x plus a over x. The next thing to do is to subtract x, so you get 10 minus x equals a over x. And then the last thing to do is to multiply by x to get rid of the denominator. So then you get 10x minus x squared equals the area. And that's pretty much it. Then you have to find the domain. I think just the domain. Yes, just the domain. So with this equation, or with this scenario anyway, x represents the one side length that we have, or that we're using. So this has to be less than 10, because otherwise 2x's will be 20 and there won't be a y, and then it's not a rectangle. So it has to be less than 10. So x is less than 10. But it also has to be greater than 0, otherwise you just have a line. So it's 0 is less than x, which is less than 10. And there's no or equals to because it just won't work. The rectangle won't work. If x was 10, then this side would also be 10, and there's the perimeter of 20, and that means the y side lengths would have to be 0. If x were 0, then the y lengths have to be 10 each, and the same thing happens, it's just, reverse, different side lengths. So that's how to do number 47. I hope you followed along. If you have any questions, refer to the Facebook group. Okay, last 2 questions that I'm going to do are 64 and 65. So this is a set of problems, and it's determine whether the function is even, odd, or neither. If f is even or odd, use symmetry to sketch its graph. So, let's do this. 64 f of x equals x to the 4th plus, no, minus, my bad, minus 4x squared. So, Broyhill taught us a nice little trick to discover whether it's even or odd. If all the exponents are even, then the function is even, and that's what it is in this case. So x to the 4th, that has 4 as an exponent, so it's even. And then 4x squared, that has 2 as an exponent, so that's also even. So this function is even. And I'm not going to graph it for you. I think you can do that yourself. And I keep putting things back in the wrong spot. Okay, 65. 3x cubed plus 2x squared. Wait, no, this is 66. My bad. 65. X cubed minus x. That's much easier. Okay, so the exponent on just a bare x is 1. You just have to remember that. So then the exponent on the x cubed is 3, so that's odd. And the other exponent is 1, also odd. So this function is odd. And you can sketch that graph. And I think that'll do it. This presentation will probably become more smooth for me as I do it more. But, right now it's still a little rough. I don't even know if I'm going to post this. But, good day to you all.